All right, guys, I thought I'd do this test review. This is your key for the handout that I gave you. That way you have the answers for it, and we'll move forward. Okay, first question. What is speed? Speed is distance over time. What is velocity? Velocity is speed plus the direction that the object is moving. And then acceleration is any change in velocity. So any change in speed or any change in direction. Does speed, velocity, acceleration relate to forces in motion? Well, of course it does. It shows movement. All these tell you about movement of an object. If it moves, then it can only have moved by an unbalanced force putting its force against that object, causing it to move. So they all show movement caused by unbalanced forces applied to the object. How does motion relate to position and time? Okay, motion. Something has to, position is distance, and so if that distance from whatever your point is, changes, then you have motion over a set time. So, position and distance. Speed then is distance traveled over a given amount of time. So that is the speed. Your motion can be calculated, and speed is how you calculate that motion. Do you have to see something to move to know that motions take place? You really don't. Sit at your desk, shut your eyes. I can move something on your desk. You open your eyes back up and see that that object has moved, and then you know it's had motion. So you can see that something has changed position. It's a result of the movement that tells you movement occurred. Okay. Then, question 4, 5, and 6, I am not going to count, so don't worry about doing those. We're going to start calculating speed. The formula for speed is distance over time, right here in this triangle right here. Distance over time. S is for speed, D is for distance, T is for time. We usually talk about it in meters per second is speed, meters and distance, time is seconds, but those all can change. We can have this as miles per hour, which is what we use when we're driving down the road. Can be centimeters per second, looking at maybe a snail moving. Meters, miles, kilometers, or even we can use light years for speed. Time, second, minute, hour, day, week, month, year, time. Anything, we use those as units. Manipulating the formula, distance, speed, and time are all given. Remember, there's a multiplication between speed and time, and a division between these two. So to find the distance, you just put your finger over the D, and it's S times T. If you're looking for time, put your finger over the T, and it's D divided by S. D divided by S. If you're looking for speed, it's distance divided by time. Utilize your triangle, it helps you out. Steps to solve the problem. Determine what the question is asking. Is it asking you speed, distance, or is it asking you for time? Set up your formula. Substitute the numbers for the letters, and then solve. Remember to put down your units. Your answer is incorrect without units. So don't forget to put your units down. Here is an example. Car traveled 110 miles in 2 hours. 110 miles in 2 hours. So what is our distance? 110 miles. What is our time? 2 hours. We're looking for what the speed of the car is. Our formula, S equals D over T. 110 miles is your distance. 2 hours is your time. 110 divided by 2 is 55 miles per hour. You see it right there. You already have your units in place. Solve these 3 questions the exact same way as those, utilizing distance and your time. considering a time problem. So you're looking at how you set up a time problem. A runner's average speed during a 10-kilometer race was 20 kilometers per hour. What was his time? So if we're looking for time, we go back to here, we cover up time, and it is distance divided by speed. So distance divided by speed. Distance was 10 kilometers. Speed was 20 kilometers per hour. Remember that if you have a units at the top, units at the bottom, or on each side of the math symbol, you can cancel them out. You need to do that. Leaves you with hours. Your time, 10 divided by 20 is 0.5 hour, so a half hour. Do these two following questions the same way. Just follow that guide that I just gave you. Now we're looking at distance. Looking at distance questions. Come back here, we're looking at distance. Put your thumb over the distance, and it is speed times time. Speed times time. So we calculate it out just like this. Speed times time. See, you decide to go to Dallas to see friends. Your friends tell you it takes 4 hours to get to Dallas at an average speed of 70 miles per hour. Approximately how many miles is it to their house? You don't know the distance, but you do know the 4 hours, and it's 70 miles an hour. So fill in your numbers. 70 miles per hour times 4 hours. Remember, hours cancel out because they're on each side of the math symbol. Leaves you with miles. 70 times 4 is 280 miles. So your answer is 280 miles. Do the next problems the same way. Now we're going to look at swimmers. You have a red and a green swimmer, and it's calculated out on a graph. It says, what does constant speed look like on a graph? Label constant speed on the graph. Constant speed is a straight line. So you have a straight line here for the red swimmer, where she ran or swam the entire distance at a constant speed. The green swimmer, constant speed, stopped, constant speed. So you have constant speed, straight line, and straight line. There's 3 spots there for that. What information does the graph tell you that the swimmer has stopped? Indicate that on the graph where it stopped. The horizontal line right here between 10 minutes and 20 minutes tells you that the swimmer has stopped, and I circled it right there. You can see where I circled it. What is the distance the red swimmer swam in all 30 minutes? So I go to 30 minutes, I go all the way up to where the red swimmer stopped. I cut it all the way across to there, 2,400 meters. So 2,400 meters. What's the average speed? We went back. It's asking us for speed. So I cover up S, and D divided by T is the speed. So I use speed as distance divided by time. 240 meters by 30 minutes gives me 80 meters per minute. Calculate the speed of the green swimmer. Follow the show formula and work. There's my formula for speed. I've come over here with the green swimmer. I see the end of the race at 30 minutes. I cut all the way back across, and I see it's 1,200 meters. 1,200 meters in 30 minutes means that she went 40 meters per minute. So the red swimmer swam twice as fast as the green swimmer. Okay, we have our 8-hour cycle race. Those are just plugging dots. Hour 1, cyclist 1, 15 miles. So 1, 15 miles, halfway between 10 and 20. I set this all up. It says, label your axis. X-axis is time in hours. Y-axis is distance in miles. And then I just went in half in 30-minute segments across for 8 hours. And then went at 10-mile intervals up the side. And I placed my dots on the line. And you can see how cyclist number 2 had a little area where he stopped and had to take a break and then completed the race. Cyclist number 1 went all the way through at a constant speed. And cyclist 3 kind of started out kind of slow and then sped up. And at the end, the actual speed that the cyclist was going at the end, number 3 was going fastest at the very end of the race. So answer the questions that go with that graph. And I will put it like this so we can see. 8-hour cycle race. Questions. During the first hour, which cyclist was moving the fastest? Now you know, cyclist number 2, who traveled 18 miles in the first hour. The other cyclist 2, did the 18 miles in the first hour. Cyclist 3 only went 4 miles in the first hour. And cyclist 1 went 15 miles in the first hour. So cyclist 2 went the farthest. Cyclist 1 had the most constant speed. And I checked it in 2 or 3 different spaces. I checked its speed. He was doing a constant 15 miles per hour. At what hour did cyclist 2 stop, and how do you know? Well, I look up here at hour 6, and I see where that straight line right there started. And I see hour 6 is where they took a break. Between hour 6 and hour 7, took a break. No distance was recorded. That's how I know. Which cyclist speed changed most during the race? Well, I look at this and I see a nice curved line. Cyclist 3 had a curved line. Cyclist 3 started out slow but ended the race with the quickest speed. What is the speed of the cyclist 1 at 5 hours? And all I had to do was go 5 hours. I saw that they went at hour 5, they went 75 miles. So my distance was 75 miles. My time was 5 hours. Calculating that out using this formula, 15 miles per hour. All right, that finishes out that graph. Questions 18 and 19, don't do. Question 20, what is the difference between speed and velocity? We already answered that, but I'll answer it again. Speed is distance over time. Velocity is speed plus direction. How can cars traveling the same speed be going at different velocities? They go in different directions. They can go the same speed, but if they're going in different directions, they're going at different velocities. 22. If you change direction, you change velocity. And if you change velocity, you've changed acceleration. Any change in speed or direction is a change in velocity. So, if you change direction, you change velocity, and if you change speed, you have changed velocity. So I could actually put in there, and if you change speed, you change velocity. Both of those are actually correct. Why is it important to know the velocity of a tornado? We need to know the velocity of a tornado because it is important to know the speed and direction so we can get out of the tornado's path. You want to get out of the way. Okay. Number 25, acceleration. Words to write the formula. Acceleration is the final velocity minus the initial velocity divided by the change in time between the two. If I'm using symbols, I'm using A for acceleration, VF for final velocity, minus the VI, which is the initial velocity or the beginning, and triangle time, change in time between VF and VI. The time between those two is this time here. Types of acceleration. What types of acceleration do we have? We have increasing, which is upward slope on the graph, it's speeding up. We have decreasing acceleration, which is a downward slope on the graph, and it's slowing down. Here is how to solve an acceleration problem. So we have a go-kart started at the top of the hill with a speed of 5 meters per second. At the bottom of the hill, it ended with 35 meters per second, and it took 6 seconds to get to the bottom of the hill. What was the acceleration of the go-kart? Ended up being 5 meters per second. 35 meters was the final. 5 meters was the beginning. 35 minus 5 divided by 6, which is the difference between the start and the finish of the go-kart going downhill. Subtract those, that's 30 meters per second divided by 6 gives you 5 meters per second. And go ahead and finish out these three equations, or these three problems, using that same way. And then here is speed, velocity, acceleration. Go back and see page 7, fill these out, and you're done. You've finished your test review. Thank you very much. Good luck on your test.